Hi, welcome back. We're in Lecture 1, Segment 2. We're talking about experimental research. In the first segment, we talked about the polio vaccine trials, a clear success story of experimental research. In this segment, we'll talk about more recent research on memory training and the idea that you can use memory training techniques or online brain games to enhance your memory and perhaps enhance your intelligence. The jury's still out as to whether this type of experimental research is as successful as the polio vaccine trials. So I'll describe one experiment to you to give you a flavor for how this works, and we'll talk about why there's still some controversy around this research. So the idea behind memory training, and you may have seen some of these things online referred to as brain games, that you can train your memory, train your attention to enhance your intelligence, is you engage in days and days and days, perhaps weeks, up to a month of memory training, and you do a test before, a test after training. That's called a pre-post-test design, to see if you can enhance your intelligence. And there are lots of websites. I'm not going to give them free advertising on here, but there are lots of websites. They typically fall under the title of brain games that promote this idea that you can enhance your intelligence by doing memory training. And again, you can do experimental research to answer this question. So I'm using my sort of basic lingo from last segment. We could promote good stuff. So if we know why this happens, why we can enhance memory and intelligence, perhaps we could promote good stuff by doing this memory training research. So the way an experiment works to get at memory training is, of course, the population we're talking about here are just all healthy adults. That's what I want to focus on. So there are some brain training games or memory training games focused at children. What I'm going to talk about today in this lecture are just some experiments designed for healthy adults. So our sample, and the sample from the experiment that I'm going to talk about, is just a sample of college students. So it's not exactly a random representative sample of all healthy adults. College students they're not random, they're not completely representative. But that's typically how research is done because we can get our hands on them here on a college campus. The way these experiments are set up is the independent variable is the training condition, so whether you go through some sort of memory training or whether you don't. And this is an interesting aspect of these training experiments. What I'm going to describe to you in this first example is a no training control group where the control group just did nothing. So there's memory training versus nothing. There's other ways to do this that are sort of stronger tests of this claim that memory training enhances intelligence. But for now, we'll just keep it simple. The dependent variable is the gain on an IQ test. So as I mentioned, subjects in these experiments, they take an IQ test before training, and then they take an IQ test after training, and we can look at the difference to see how much does an individual subject's IQ increase as a function of training. So the dependent variable here is IQ gain. The idea being that subjects in the training condition, their IQ is going to increase more so than subjects who are assigned to the no training condition. Okay? So the procedure in this one experiment that I'll describe to you is the treatment group, the memory training group, they engaged in memory training for half an hour a day, every day for weeks. I think it was up to like 4 weeks, 4 or 5 weeks. And I'll show you the training procedure on the next slide. And as mentioned, they took an IQ test, a reliable standard measure of IQ, before and after training. Now here's what the memory training paradigm looked like. If you're not familiar with the idea of working memory or short-term memory, this may look a little odd to you, so let me take some time to explain it. This task is called a two-back task. And very simply, what you're supposed to do as the student in this task, or as someone who's engaging in this training paradigm, is you're going to see stimuli pop up on the screen, or you're going to hear stimuli presented over headphones very rapidly, one at a time. So you're going to see either locations, squares show up in different locations on a screen, or you're going to hear letters presented to you auditorily over headphones. And your job is just to press a button when the stimulus on the current slide, the one that you see or the one that you hear, matches the stimulus N back in the stream. And in this example, you're just doing a two-back task, which is actually a pretty easy task. We could start with one back, but that's really, really simple. So in a two-back task, this one right here is a visual target because it's in the same location as the stimulus two back in the stream. Similarly, in the auditory stream, this one is an auditory target because it matches the one two back in the stream. In this case, this is known as a dual N-back procedure. The subject was supposed to press the button only when the stimulus matched in both the visual and auditory stream. So again, this right here is when the subject would press the button saying, yes, this stimulus matches the one two back. As I mentioned, subjects in the memory training condition, they engaged in this training procedure for half an hour a day, every day, up to 19, you can see 19 sessions down here on the x-axis. So what I'm plotting here on this graph is on the x-axis is session number. So how many training sessions did they engage in? And what I'm plotting on the y-axis is the mean N-back score. So as you can see, people started out down here around 3 back, and as they engaged in training over 19 sessions, 19 days of doing this for a half an hour a day, they got better and better and better, up to about 5 back. Some people probably got as high as 6 back. Okay? So if you've done this task before, if you have any familiarity with some of these brain game websites, 2 back is really easy, 3 back is sort of challenging, 4 back is really challenging. So the fact that these people got up to about 5 back is pretty impressive. So they're clearly training something. The jury is still out as to exactly what they're training. So some people argue they're training a core memory capacity that's related to intelligence. Other people would argue that they're training, they're just getting faster at doing tasks online or something else. But these are some of the basic results from this study. The bigger question is whether there was transfer to intelligence. So people clearly get better at the task that they're training in as they do the training procedure every day. The bigger question is whether those people in the training condition got better on the intelligence test relative to a control group that didn't do the training. And here are the results from a study by Yaki et al. The reference is here. If you want to look it up, it's Yaki et al. 2008. Here is the primary result from that study that caused a lot of buzz and generated a lot of attention in this area of research, is if you look before the training, so what I'm plotting here on the x-axis is pre and post, so this is just time. So before training, there's no difference between the experimental group and the control group. That is, between the memory training group and the placebo group, if you will, the group that did no training. There's no difference in their intelligence score. So what I'm plotting here is their score on an intelligence test. But what you see after training, so post-training. The group that did the memory training procedure, they gained more on the IQ test than did the group that didn't do the training, the control group. The control group went up a little. That's probably just a practice effect. They took this intelligence test before. This is their second time taking it. So there's a little bit of a practice effect. But the bigger point is this difference here. The group that did the training gained more than the group that didn't do the training. So the conclusion from this experiment then is engaging in this memory training procedure, doing this end-back task for a half an hour every day for 19 sessions, not only enhances your ability to do that end-back task or enhances your memory capacity, but it also, according to these authors, enhances your basic intelligence, your general intelligence. And that, of course, created a lot of excitement in the field of psychology and education, because the conventional wisdom in those fields is that intelligence and sort of memory capacity are sort of fixed once you get to adulthood. It's very hard to change your level IQ. And this result right here called all of that into question. Now, as I said, the jury is still out on a lot of this work. So I said here, does it really work? There are lots of people who argue that this does not work and this is a fluke result. Yaki et al. Have followed up on this research and argued no, that this result is real and that you can engage in these memory training tasks to enhance intelligence. My perspective on this, I do research in this area, I study working memory and intelligence, is I would argue so far there's not enough evidence to suggest that these things really work. So if I were you, I would not go out to these websites and spend any money on these things, not just yet. I think we need more experimental research to get at, to see if these results are really strong and if we can replicate them with different kinds of memory training paradigms, and most importantly, with better control groups. So in this example, the control group did nothing. So that's a really poor control group. So when you do experimental research, you really want the difference between the experimental group and the control group to be as small as possible so that you can make that causal claim about why the outcome happened. You can link it to that small difference between the experimental group and the control group. Here, there are so many things that were different between the experimental group and the control group. The experimental group came to this lab every day for 19 days. They got better on a task that they were doing on the computer every day, so it was rewarding. They felt better about themselves. They had maybe just a more positive feeling about this lab, about cognitive tasks in general. So when they came back for the post-test on the IQ, they could have just done better because they felt better about themselves. They could have felt better in that environment. There's all sorts of reasons why this result could have happened that has nothing to do with memory training per se or IQ per se. And if you're interested in this line of research, again, you can just Google working memory training. There's lots and lots of studies now on that topic. Again, I would argue that the evidence isn't strong enough to claim that this really works. Clearly, it doesn't work like the polio vaccine worked, right? So this is an example of experimental research that's not quite as good as those polio vaccine studies. Okay, this is sort of not sort of high quality experimental research. Lots of potential confounds. Okay, so to summarize, this is the same summary from segment 1. The major benefit of randomized controlled experiments is that they allow for strong claims about causality. They allow us to get at mechanism, why things happen. Again, we can predict stuff that allows us to prevent bad stuff like polio, and potentially allows us to promote good stuff like intelligence. If we could use working memory training to enhance intelligence, then great. That's a great idea. I think everybody's behind that idea, but not everybody believes that it really works so far. And I'm still pretty skeptical myself. And again, that's because we need really good independent variables, random and representative samples. Again, that was another problem with that study. It wasn't truly a random representative sample of all young adults, right? It was college students. And we need no confounds. And there are lots of potential confounds. I encourage you to post on the discussion forums your own ideas of the potential confounds in this line of research. There's lots and lots of confounds that I didn't mention here, but you could mention in the discussion forums if you like. So this is an example where it's true experimental research. It's true that those subjects came to the lab. They were randomly assigned to do either training or no training, and they were assessed on some dependent measure. So it's a nice example of a randomized controlled experiment, but it's an example of an experiment that doesn't allow for strong causal claims yet because of all these potential confounds, unlike the polio vaccine example.